So if you don't have any questions, so our agenda for today will be to cover this. Okay, these are the points that we need to cover, and what it is, we have a box plot. We'll see what box plot is, and we saw basics of visualization in last session. Okay, we saw histogram, we saw pie chart, bar plot, line graph, and everything. We'll see box plot, and specifically why we are seeing it in a different context altogether, not with the visualization, because it has a significance, statistical significance. Okay, we use it a lot when we do exploratory data analysis. So we'll see box plot, then we'll see outlier, and box plot and outlier is directly related. It has a very close, like, one-to-one implementation rule. Okay, we'll see that how we use outlier to we use outlier to using box plot, and how we use box plot to detect outlier. So there's a dependency in both of this topics, so we'll see that. Then we'll see basics of apply family functions. What is apply family functions, where do we use it, why do we use it? Okay, and few implementations of it. And since I'm calling it as a apply family functions, so family means like there must be a group of functions. Okay, then we'll again we'll start continuing with this dplyr. We have seen basics of dplyr, we'll see some advanced topics of dplyr, probably the one which is left out. Okay, then we'll see merge tables. So merge tables is nothing but merging two data frames. So we have whatever we have seen till now is individual data frames. Okay, so there can be a scenario like where you need to work out with multiple data frames at a time. Okay, so in that case, how merge is used. Okay, so we'll see that. Then finally we'll end up the session with assignments. Okay, I'll start giving you assignments from today's, because we have covered at least some basics and mid basics of R. Okay, based on that I'll share assignments with you. Okay, you need to complete it. Okay, and like we'll discuss assignments and solutions in the next sessions. Okay, this will be the like rule that we'll follow from now onwards. Okay, and you need to look into these assignments and solve it, like, individually. Like, we need to give some time, we need to learn this, because this is an actual learning. Okay, you'll have to retrospect yourself how much you have learned and where it is a problem, so that we can bring that problem and we can discuss in the sessions. Okay, perfect. So let's move ahead, guys. Like, this particular codes I've already shared with you. It's for exercise 4.0_01. Okay, so we'll start with the questions for today. That is I got only one question, that is n. Okay, so n is basically used when I need to uh, check that if I have that particular item or element in a given list, array, or a data frame. Okay, let's say for example I have a like, let's take a very basic example. I have one vector. Okay, it has 1 2 3 4 5, let's say, and then 10. We have 6 elements: 1 2 3 4 5 and 10. Okay, I created a vector. So if I want to check my element is a vector, so it is 1 2 3 4 5 and 10. Okay, but at the same time, this is very small. Now if I want to know if 2 in x, so what I'm trying to do is, this very simple example. I'll give you the real life experience, but to understand it is best. Okay, I have a very small vector x, okay, which has these elements. Now if I want to check if particular element 2, or let's say 2 3, whatever it is, does it exist, or is it a part of this vector x? Yes or no? Okay, so for that situation, or to clear out that confusion, if for particular element belongs to this particular data set or not, if this particular element belongs to this data frame or not. Okay, so we use in operator followed by ampersand in ampersand. Okay, so this is the operator. How we write it? Ampersand in ampersand, and you will see this will get grayed out. Okay, now you got the answer true. True means like, yeah, the element which you are looking for, the element 2 is in the vector x. Let's say now we'll check for element 11. Okay, this is my element in x. And if I enter it, I get false. What does that mean? That means like 11 is not there in a vector x. Guys, clear? Now, to understand the real-time implementation of it, in a real time, the vector or the data frame or the column will be having like thousands and millions of rows. Okay. Now, if you want to check if a particular person, like let's say Sajid, is he there in the list or is he there in the column as a candidate? Okay. So you cannot go individually and look for it. Okay, that will consume lots of your time. So you'll have to use such operators to check, yeah, it is there or not. Okay. So am I clear, Antika? You asked this question. Fine. So let's move ahead. Now let's start with. Let me check if I have any questions. Yeah. So there's a question. What is the use of operator? What is the use of this operator and this operator? I don't think that we have covered this. Okay. This is called pipe operator. Pipe operator. We have the entire we'll dedicate an entire session in this. This is a pipe operator. We have not covered this. Okay, we have a upcoming sessions where we'll cover this in detail. Fine. So let's see a box plot. Okay, what is box plot and where do we use it? Okay. Now, just for the example, okay, I am trying to import a sample data set. Okay, and the sample data set is CU. Then it is in chapter wise, chapter 4, I guess. Yeah, it's in chapter 4, examining outliers, and this. Let me import it. Okay, so I've imported like a very small data set. It has all the OS, mobile OS, and how many users you have for that OS. Okay, so you can see like Android is leading the market, then iOS, then Windows, BlackBerry, and all. Okay, so this is my data set. Let's have a look. I'll look it here. Yeah, this is my data set. Just have a look here. Okay, you have Android, you have iOS, Windows, BlackBerry, Linux, Symbian, and others. Fine. This is the like number of users. Probably it is in million, 162 million, then 37 million, 7 million. Okay, and then this is the proportion. Okay, what is the proportion of Android users over other? So 75% is covered by or captured by Android. Okay, likewise. Now, first of all, what is outlier? What do you understand by outlier? So outlier is something which does not belong which does not belong to a particular data set, you can say. So if I draw, sorry, I'll just draw something for you to make you understand well. So I guess you are able to see the whiteboard. Okay, let's say this is my x y axis. and this is my data points. I'm plotting it here. Guys, okay, and one I have one data point here and one data point here. Now let's say I have something here as well. You have few data points here. Okay, now this is my distribution. Let's say this is X and this is Y. This is your X and Y, and to be more precise, let's say you have this is your sales. This is your sales. Okay, and this is your advertisement cost. Okay, so this is your sales and advertisement cost. So we see, like, if sales increases, we see some increasing trend. When we increase the sales, sorry, when we increase the advertisement budget, okay, we see that there is increase in sales. Obviously, right? When you put more money on advertisement, so some sales will increase, right? This now I see major chunk of it. The major chunk of your data is residing here somewhere. This is a major chunk. You see the data is concentrated. Okay, but at the same time we see there are some points which is lying, which is again sales only and recorded sales. Rather, I to be sorry. This is sales, but these two are points which are lying outside the concentrated portion of a data set. Okay, so in a technical term and statistical term as well, we call this as an outlier. Fine, we can detect our outlier. How we can detect it? If we have a given data set. Okay, let's say you are doing a project or you're working in a real-time project, and you've been given with a data set. Okay, so the first or the initial steps you have to check, does the data have outliers or not? Okay, and what is the simplest way to check if your data has outlier or not? Do a scatter plot. Okay, plot that particular column which you are trying to check in a xy plane. Do a scatter plot. Okay, normal plotting. So once you plot it, if you see visually, because visual detection is the best detection for outliers. If you detect it in a plane, xy plane, you see any particular points or 2 3 points which is lying ahead or away from the concentrated portion of the data set, that means that is a, like, subsequent, you can say that's a outlier. Okay, that is the first way. So we used that way here. We have plotted the data, random any data, and we saw that 2 points are lying outside the concentrated portion. So this can be the outlier. Now detection is done. If we go back and we should know, like, why, how does it at least bother to us, like why we are bothered about outlier. If data has an outlier, let it be, right? So we'll see how it matters. Okay, now let's say I'll create again the same small simple example of a vector. I have a vector 2 4 6 2, sorry, 2 3 6 5 4 8 7 10. This is my small vector just to demonstrate. Okay, I created a vector x. Now I'll check what x has. So similar, like, obviously whatever the elements which I have entered is there. Fine. Now if I need to find a mean, I'll come into statistical. Like, this mean is very simple example for you. If you want to perform any statistical operation, okay, standard deviation, like you want to find variance, mean. So let's say mean. I find the mean of x. I get 5.75. Okay, so if I see visually, so this data sets are in a range of 1 to 10. Okay, all the entire data set ranges from 1 to 10. Okay, and I got a mean of 5.75. Now if I have a data set, something which is like this, so there's again just one more element, but that is 100. Okay, and I create a vector again, the same elements, and I try to find the mean. Okay, so now with one element, that is 100, my mean is getting deviated by almost 11 points, 11.5 points. Okay, now if I consider this, if I don't do any outlier check or outlier detection, outlier remover, okay, so whatever I'm going to predict about this sample, let's say this is my sample, that will be 100% that will go wrong. Okay, if I say, let's say this is the age of a person, and I say that average age of a person is 16, okay, that is going to be wrong. Do you agree, guys, with me? The average age of a sample is 16 will be a wrong statement. Okay, now if we retrospect this, what is making this? We are properly doing mean, like to find a sample mean, we use mean function, everything is fine, but the problem is with the data. So we'll have to check on the data, because if we don't do it, so our predictions or our recommendation will go wrong. Okay, now if you plot this box plot, we'll come to box plot. Okay, let's not get confused here. So this is your data set. You plotted or you found a mean. Okay, we saw that you have 100 as one element, and the other element lies in a range of 1 to 10. Okay, so logically, what you are going to do is, you see straight away you will not consider this 100, because since this is 1, if if it would have been like 100, 101, 105, 110, then no need to remove it, because yeah, you have some sample which is ranging from 1 to 10, and you have another sample which is ranging from 100 to 110. Okay, so this is not removable, you cannot remove this. In this case, this is well, this is fine. But if you have only one or two data points which is lying away, in that case that is truly an outlier. You have to work with it. Okay, and what is the workaround? You will have to remove it straight away. You need to remove it. If one or two points is there, you will have to remove it. Now I create this dataset which I had, and now let's check if I box plot it. I plotted x. Okay, I plotted x, and what was there in x? It is 1, 3, 2, 3, 6, 5, 4, 9, 7, 10, and 100. Okay, this was my box plot. How do we plot a box plot? We write box plot and the dataset name. For more details, simply you'll get an entire code here, box plot, and check here. It will be having a detailed description, because it is used in many different situations. Okay, go through it once. Okay, this is, and check the code box plot, and then what you want to check on, like do you want data, any relation you want to fill in. Okay, so you can look at it. Now coming back to our box plot, so I'll write box plot dataset name x. So this is my box plot. So first I'll show you a normal box plot. How does it look with a normal dataset? So I'm taking a normal dataset. I create this, then box plot y. Let me run this. So this is a box plot. Now let me zoom this. This is a box plot. Now it has few terms that you need to understand. First, this part. The uh, yeah. So if you see this part, the entire box plot is divided into 4 sections. Okay. So this is your first section. This is your first section. Oh, how to write it? This is your first section. How to highlight? 1 minute. Yeah. So this is your first section. Okay, here. This is your second section. Let me write it here. This is your second section. This is your third section. And this is your fourth section. Okay. Now we also call it 25%. Okay. From here to here, this portion is from 0 to this refers to as 0%. From 0 to 25. Okay. From 25 to 50 here, 50% I'm talking about. Okay. Then 50 to 75 here, and from 75 to 100 here, this portion. From 75 to 100. Now the one which is the at the bottom, this portion. This portion is called lower whisker. This entire portion is called lower whisker. Okay, and this is called upper whisker. Fine. Now this box. Coming to this box represents the volume, and the line you see here is it represents the medium of the sample or the data set which you are retrospecting. Fine. So these are the terms that you will have to understand, and majorly it has 25%, 50, 75, 100. Okay, this medium line box represents the volume. Lower whisker starts from 0% to 50%. Upper whisker starts from 75% to 100%. That is it. Okay. Now come to outlier. Anything which is below lower whisker. Okay, this is your line. This line is your lower whisker. Anything which is below lower whisker or above upper whisker will be termed as an outlier. Okay, now you can ask me, like, this upper whisker is ending at 10. Okay, this upper whisker, if you just refer to the axis, so it ends at 10 somewhere. So if a point which is at 11 can be, okay, probably it will be covered in the box plot. If the point is in, if a point is in 11, 12, 13, so this line will get stretched. Okay, no issue, but I'm telling you, just like try and understand this. If a point is in 11, will that be an outlier? A point which is there in 90, will that be an outlier? So the logic is 1.5 of the interquartile range. Okay, now what is interquartile? Let me remove all this. So like what I said is just let me repeat. Anything which is below lower whisker and anything which is above upper whisker will be an outlier for you. Okay, now the situation is, will a point at 11, let's say here we have a data point. Okay, this is one data point, and we have a little data point somewhere in 90. This is 90. Which will be an outlier for you if you are trying to inspect manually? If you're trying to look and then see the numbers and then conclude, yeah, this is an outlier or not, how will you term it? Okay, so theory says anything which is 1.5 times 1.5 in sorry 1.5 times 1.5 into interquartile range. We call it IQR, interquartile range. Now, what is interquartile range? What is quartile? This is quartile. This is your first quartile, Q1. Okay. Then this is Q2, second quartile. So you can relate it with the percentage which I termed you in the very initial stage. 0 to 25, 25 to 50, second quartile. Then 50 to 75 is your third quartile. Then 75 till 100 is your fourth quartile. Okay, getting a point? Now what is interquartile? Interquartile is this minus this. This will be your interquartile range. Okay, probably I'll draw it again. This portion. This portion is your I, Q, R. Fine. Now we'll use this is the logic which is used everywhere. Let's say this IQR came is for you for this example is 10. Okay. Now this upper here we see the upper whisker is at 10. Okay, and IQR is also 10. Let's say there's a point at 15 here. Will this be termed as a outlier or not? So coming back to a calculation, 1.5 into 10 is how much? 15, right? So 15 is just at the like boundary of an outlier. Okay, now let's take another example. Let's say this point is at 17. So your theory says 1.5 into 10, that is 15, is your upper boundary. Above that, everything will be outlier. So these 2 points will be an outlier for you. Since this point is at 11, this will not be an outlier for you. Anything which is at 14 will not be an outlier. So same logic at negative side will be applied here. If anything is at minus 20, so this will be an outlier for you. Anything which is at minus 5, that will not be an outlier for you. Okay. Now what is the beauty of boxplot? Boxplot will not like ask you to define the which is outlier or not. It will automatically consider this, automatically consider the point as an outlier if it is. If not, it will not consider it. Okay. So just the idea just to show the entire calculation was, if you are doing it manually, okay, if you are doing it in Excel, okay, in Excel 16 they have this box plot. If you open Excel 16, If you have Excel 16 in your system, you can do box plot there. But below that, like Excel 13, Excel 10, Office 13, Office 10, they don't have this box plot feature there. Okay. I hope you are clear. Now I'll show you that depends, like so the question is 15 is on outlier or not. So it is at boundary line, yeah, it will be considered as an outlier. Now let's move ahead. I showed you the entire calculation. Now let's see what does. See this. Yeah. So yeah. So now what we did is we saw the calculation, the entire quartile concept, everything. Let me come back, Antika. Let me come back on this. Okay. See here. This is my data set. I did a box plot. So this is my box plot. What you see here is a box plot. Okay. The moment I insert a new variable, let's say 100. Let's say 100 I plotted, and I run that. 1 minute, yeah. From where it came. Yeah. And I run this. Create a variable box plot. Sorry, this is why. Box plot y. So see here, your entire box plot is getting squeezed. Okay. See, your box plot is getting squeezed, and you see a point away, there's a dot. So what boxplot does is automatically it says, yeah, this is a outlier, and it squeezes itself. The moment this is detected and you remove it, the boxplot automatically retakes its size. Okay, it automatically regains its size. Now take an example. The moment you remove 100 and create it again, it regains its size. So this is the best way. And how does it, you can say, like, why 20? Let's say 20. Okay, and we create this. Why 20 is considered outlier? So do the calculation. Okay, do find the interquartile range. To detect it, just to retrospect it, you have to do this interquartile range manually. You have to find the mean first. Okay, and you see 20 is detected as outlier because it is. If you do IQR, IQR is not plotted here. We'll see how we plot it, because they'll point the out IQR as well in some feature of box plot. Let me check what is the command. Getting IQR. I'll check the command. I'll tell you. Okay, I'll probably do it in next class. Okay, where you'll get the uh, IQR of each. What is the interquartile range? It will come from the formula. IQR can be interquartile range. Let me do it here individually. IQR. So I want to find IQR of Y. Let's see what it gives you. IQR. So IQR is 5. So 1.5 into 5 is how much? 7.5, 7.5, and this 20 is more than 7.5, so it is an outlier. Now let's say I do 1.5 into 5 is 7.5, I give 8. Like what about this? So it is considered in the box plot, so this is not detected as outlier. Okay, guys, are you clear with this? Now let's move to our example, the data set which we already forgot. Where is the data set? Yeah, the data set which we imported. Okay, the idea was to check in a real time how it helps. Okay, now you see there's among these competitors of mobile OS, there are some leaders, okay, sub leaders, okay, and there are very small competitors as well, like Symbians. It has very small market captures, 1.2%, okay, 1.2 million, and the others has 0.1 million. Now, if I plot, let's say I want to do a simple plot. I'll not do a subset now. So I'll do a box plot, and I want to plot this OS dollar. I want to see proportion or some millions. So what I see is there's a market leader, okay, which is somewhere around 1 point above 150. So that is Android, fine, and remaining fits in this box plot. So one either this 162 is an outlier for you. So if you see this and consider the let's say like some, if you give some statistics using this, so it will be a wrong assumptions. Okay, so you'll have to deal this separately. Okay, so what is the way I told you, and that is the only way which I told you. You have to remove it. Okay, you'll have to take a subset of it, or you'll have to normalize the data. This is the second option. Probably what I do is, like, generally what I practice, if you have an outlier, just I do scatter plot, then box plot. I try and find it, significance of it, check the significance of it, and we have to remove it. That is the way. Okay. Now, if you have any questions, just put it forward. We'll take the questions now. Try and remove it. When we see it visually, like in the scatter plot or a dot plot or a box plot, we remove it. Sorry, box plot is what it automatically handles. Okay. If you are doing a scatter plot, so we remove it. In a box plot, automatically box plot takes care of it and the calculation we have seen. Okay. Now that is it. So other aspect of it will be, let's say a good example which I would like to take you through. There's a data set called river that is there in R. You just check, and it is a data set of a North American rivers flowing in North America. Okay, it has lengths and everything. Just have a look. Now I want to see what you have, like in a I'll plot a histogram. So this is the bins you see. Okay, it varies, the frequency varies from 0 to 80, which is not needed for us since we are studying a box plot. I'll plot a box plot. So box plot has a various parameters, which you'll see when you just type box plot. You'll see it has n number of parameters here, and it has everything has its own use. And frankly speaking, we don't use all. Okay, very few of them. Like one is horizontal. Horizontal is equal to true means, like, how do you want your box plot? Do you want it in a horizontal way or a vertical way, which is in which you are more comfortable in? Okay, likewise you'll change the parameter and you'll use it. Fine. So box plot, I'm doing plotting the reverse data set, and I'm doing horizontal is equal to true. So see what we saw last time, that was horizontal is equal to false, that was vertical, not horizontal. Okay, so there's a box plot, and at the same time you see there are points which is above, okay, towards right, of a upper whisker. So what I conclude is this data set has an outlier. Okay, now you'll have to detect it. You already detected. Okay, how you detect it? You straight away followed the concept, like anything on the right, if you are seeing the horizontal, or anything above the top whisker is an outlier. Okay, and what you see here, the top point is somewhere around more than 1000, less than 1500. Correct? It is the top whisker lies somewhere around, like somewhere more than 1000 and less than 1500. So you need to remove anything which is greater than, let's say, 1100 or 1200. That will be an outlier for you. So that is what it is done here. They simply filtered out boxplot stats. So it will give you like upper whisker, lower whisker. Okay, so stats says this. This is your fourth quadrant. You need to remember this. So this is your fourth quadrant. So how will you, there are two ways. How will you get to know, like, which, what is the point, what is this point, upper whisker? It should, because in the graph it is not showing, we just can see it is more than 1000 and less than 1500. But if you want to see the exact, so there are, if you remember, we have seen summary which give you all the statistics. Okay, remember, we have seen this. So you can use summary, or you can use boxplot stats. So probably we'll go for boxplot, since you are learning boxplot. So we'll see boxplot stats, boxplot.stats river. So it will give you all the coordinates. So 0, first, second, third, fourth. So what is the top point? 1205, and we rightly predicted that it is greater than 1000, less than 1500. So if you remove all the data sets that is more than 1205, that means you are removing all the outliers. How will you remove? Simple, uh, like we checked, we did this, how to manipulate data, or how to over remove data manipulation in R. Okay, so reverse reverse less than 1210 you will consider low. I'm creating a new variable called reverse dot low. Okay, where I'm considering only the value which is less than 1210. Okay, let's create this. Now again I'll plot a box plot. So I plot, I see again there are again 2 3 points which is more than 10,000 but less than 1200, less than 1200. Okay, so another, this is a hidden trial method. So I'll check, it is 11, what is the, like, points. It is 1171, 1100, 1205. So I'll remove anything which is greater than, let's say, 1100. Okay, and I'll do this until I get a box plot without any outliers. So that is my perfect box plot. That means I have a perfect sample. Okay, a sample which is free from outlier. I can conclude, or I can recommend anything. I can do statistical recommendation on that data set. That is the whole idea. Okay, so this process which I have shown you, this block boxplot dot stats, this is just one way. Okay, majorly what we do is we do scatter plot. From scatter plot we point out the data set which is, and the points, the value of it which is lying in an outlier section, and we'll try to remove this, and we'll try to make our data set, sample data set, as free from outlier as we can. Okay, so I have some questions here. Yeah, so Ekta, removing an outlier, there are various ways. The very basic and majorly used is scatter plot, and visually pointing out the data set, data points which you think or which should which we feel like it's an outlier. Okay, first thing. Second thing is, if you don't want to do scatter plot, bring that data into a box plot. Okay, the moment you bring the data into a box plot and plot it, box plot automatically will point out the outliers. Okay, and on what basis, on what principle it is pointing out the outlier is that interquartile range into 1.5 divided by n ka whole root. Okay, that is the concept. Look at it. Okay, so these are the two major ways. Now, once the box plot or a scatter plot points the outlier, you need to remove it. Straight away remove it. Okay, fine, perfect. So yeah, come again. Yeah, what's the question? Yeah, bring it. Yeah, Sanjana, what is the question? With which example? This example? How it will be an outlier here? Because it is falling in the range, right? If you see 2 to 10, if what is my mean? Mean is 2, max is 10. Okay, and the and 8 lies in between that, so it will not be an outlier. So if you are referring to the earlier formula which I have shown you, so there is a change, little change in the formula which I have. Uh, this is the formula. Okay, where is it? I saved it somewhere else. Anyways, it should be here. Yeah. So there's a change in formula. Check this. Use this. Okay. Correct. Yeah. I'll ping it in to everybody. Fine. So let's move ahead. And this data set is there with you. Just try and follow it. Okay. We'll move to our second topic. We saw box plot. We saw outlier detection. Now we'll see apply family function. Okay. So guys, apply family function is something which we use very frequently as we keep on using R. It's just a way, like it's not like apply family function is like you need to use it. Okay, there'll not be any situation which will ask you or which will restrict you, or for which apply family function is the only solution. No, because apply family function is something which is made to make your job easier. Okay, and how will you find it efficient when you keep on writing codes? Okay, and you do something and you find like you are writing the same thing again and again, or you can optimize this with small codes. So there comes apply family function. And what is the dependency is you can use apply family function in a data frame. Okay, as I said you earlier, like data frame is one of the, like, it is one of the best data types of R, Okay, and it has one dependency. What is the dependency? Because many functions or packages, they are mostly built for data frames only. Okay, so apply family function is one of them. Now let's take, there are so many types of apply family function. Okay, you have lapply, sapply, v, m, r, t, and believe me, the difference is very subtle. Difference among them is very subtle. So we'll see the very common one, lapply. Okay, how does it differ? That is most important. So the difference is what you are getting as an output. Okay, now let's say we'll take this cars dataset as an example. Do you have? Let's not take. Let's create a matrix. Let's create a matrix. There's always matrix created, so I'll just use it. So what is M? M is a 4 by 4 matrix, guys. So see here, I have created a matrix. The value is ranging from 1 to 16, sequence 1 to 16, and 4 by 4 matrix I created. Okay, so it has from 1, M11 is your 1, M44 is 16. Okay, this is 4 by 4 matrix. Now if someone asks you for each row or for each column, find me the minimum or maximum value. Okay, if this is a small matrix, you can definitely see the matrix and you can say for the first row 13 is maximum, for second row 14 is maximum, for third row 15 is maximum, for fourth row 16 is maximum. Likewise, you can say for first column 1 is minimum, for second column 5 is minimum. Likewise, okay, and similarly you can do many other operation. You can find sum all the rows, find the square root of all the rows. Okay, the situation is, or the case scenario is, if you have a data frame matrix where you need to do a row wise operation, and that operation needs to be done for all the rows. Now for all the rows, what I mean is, in a real time you'll have thousands and millions of rows. Okay, doing it manually is impossible. Okay, doing it using loops, we saw loops, right? We can do this with loops, but it will consume lots of time and lots of resources. Okay, so the rescue is family function. Apply family function. Now, as I say always, anything new, question mark, ask R what it says. Okay, so R is very well documented in this case as well. Just read it. Okay, you have a family functions apply. X is your data frame or a matrix. Okay, then margin is like the operation you are trying to do, whether it will be a row wise operation or a column wise operation. Okay, one indicates row, two indicates column. There, I'll just write it here. X is your data set, margin margin. X will be one will be row, one represents row, two represents column. Okay, and what you want to do, function. Function means like whether you want to find mean, max, square root, sum, standard deviation, what you want to do, function. So this is the entire story of, in terms of coding. Okay, now just see example of it. Let's say this M dataset, M matrix. In this M matrix, I want to use apply family function in M matrix row wise. Row wise means 1. Okay, what I want to do is I want to find max. Okay, run it. See what you got as an answer is, for first row 13, second 14, third 15, for fourth it is 16. Okay, clear? Now same thing if I want to see column wise. So everything will remain as it is. Just copy this and change the margin. Margin will from row wise to column wise. Run it. So you get output column wise. So what I'm trying to find is maximum column wise. For first column, 4 is maximum. For second column, 8 is maximum. And likewise. So this has many things like you can find minimum. Okay. You can even do column wise operation minimum and all that. So that is there. Now this is normal apply. And this is what we use very frequently. Apply. They don't have any like prefix L, S, T, R, M. That does not have. Okay. Now, how does it matter? Okay. First, you need to understand this. Since this is done, other family, like let's say L apply. Okay. How does it differ? Is it differs in the return type. L apply will give you a vector as a return type. Okay. S apply will give you a like array. Okay, someone will give you a map, so complex data types. So that is the only difference. Entire concept remains same of L apply, S apply, T apply. And it has also one dependency, like L apply might not accept a vector. Okay, so that is something to look at. Yeah. So Sumit, what is the question? Can't we see the max or mean of a single row or a column? Means you want to see only like I didn't got this question. Yeah, so if I'm not wrong, so if you're telling like you want to see a max or mean of a particular column, okay, for that why will you use apply family function? Just write up max that matrix, and in matrix I don't know, it is not possible because in matrix it is possible you need to subset it. Okay, let's say you want to see the max of matrix M of column 1, so all the rows column 1. Okay, so 4 it is. You need to subset the matrix. Definitely you can see, and in a data frame, let's say simple max. What is the data frame? Let's say I want to see the data frame from car. Okay, I want to see the max of distance. So you get 120. So seeing it individually is not an issue. It is all always there using a max or mean function. But I'm talking about a situation where you have a tabular format, data frame, matrix, okay, and you need to find a max or mean of each column or each row. In that case becomes very difficult when you have huge entries, and apply family function is important there. And you can keep this as a note. Okay, if you're sitting for an interview and if 5 question is asked from R, okay, one question will be from apply family function. Okay, just make a note. This is very very important, and like it's kind of confusing, but since you once you start doing it, it becomes very clear to you. You're clear. Okay, so I'll share the code, just have a look. Okay, go through it. What else in this? S apply returns a vector. So I have written the theory. How do we differentiate between S apply, L apply? So S apply is similar to L apply. Now we'll see what is L apply first. Okay, L apply returns vector. That's what I told you. S apply is a similar to L apply. The only difference is that the output of L apply is always going to be a list. Okay, L means list, so L apply will always return you a list, whereas S apply will return you a vector. Okay, as simple as that. So I've written this. I'll share this code. You can make a note. Fine. Similarly, if you want to see M apply, M apply is a multivariate version of S apply. Okay, majorly used when you have multiple objects. So since we have dealt with one object, so M apply will not be applicable there. But just to know, just keep the theory with you. Okay, fine. So I guess we are okay with it. Let's move ahead and see what's there in our next dplyr. Okay, dplyr we'll look at. We are looking at dplyr and we definitely will. This will go along. This is very important. Okay, now I'll like to start with merge. Okay, this is something new. Merge. Okay, now before we go to my example, I'll just uh, try to make you understand what merge is. Okay, let's see a iris dataset ahead of iris. Let's say I see 10 dataset. Okay, now I have a table. Okay, this is the first table, df1. Let's put it here. I'll put it here. The reason like why I'm emphasizing here in a separate sheet is this this is important and this will be used a lot. Okay, and like a lot means like when you try to solve a problem and the data is in tabular format, this will be used. Okay, and you always have a data set in a tabular format, so you can understand the importance of it. Okay, now you have a data frame called employee. Let's call it a table to make it small. You have a table called employee and you have a table called department. Table called department. Okay, now in table employee, what you have is employee ID, EMP ID. Okay, EMP name. Department, what you have, employee ID and then employee department department, and let's say one more column, department employee phone number. Yeah, employee phone number. You have this is your data set. So let's say employee 1 xx, employee ID 1, department economics, and then mobile number some yy something. Okay, fine. Now let's say you have this you have 1 million record here and you have like 10,000 records here, whatever it is. Now I have two tables. If the situation comes, and definitely this is a real-time scenario, every now and then you'll get this. Okay, you need to find what is the department of employee 1. Okay, and you came to a data set and you saw that what the question is, what is the department of an employee whose employee ID is 1. So how will you find it? You'll not be able to find it if you just look at one table, because in this table you have only two information: table name and sorry, I'll just redefine my question here. Okay, I need to find an employee name and employee department of employee ID whose employee ID is 1. Okay, now I cannot do it in a single table, because in this table I have employee ID and employee name and employee department is missing. Okay, we cannot use this table, we'll have to discard this. Now we come to second table which is available to us. It has employee department and it has employee ID, but it does not have employee name. Okay, again we'll have to discard this because this is not used for it. Employee name is not there, so our requirement is not being fulfilled here. Okay, you had only two options and you have discarded both of them. So from where you will get the data? So the data will be a situation or a scenario where you have to join these two tables. Okay, what I mean is like you have to merge these two table to find what you are looking for. So once you merge these two table, then that table will have employee ID, employee name, and employee department. So your situation or your requirement is being fulfilled. Okay, that is one solution, and that is the only solution. Okay, now the question is, how do you merge it? So merging has a very basic requirement. One very There's one very basic requirement. Okay, and that requirement is there should be one common column between the two tables you are merging. Okay, let's say you are merging table employee and table department. Okay, so there should be one common column, as I said. So what is the common column? Employee ID. Okay, you will merge on employee ID. So once you merge it, so how it will look? The third table will be something like this. It will have employee ID. It will have employee name. Okay, employee ID is already there, so it will have employee department. The column name will not get repeated any time. Just make sure employee mobile number. This is your third table, which have four columns. Okay, now here give employee ID 1. What was the required? You have XXS name, department is eco, and mobile number some XXXYY, whatever. Okay, so now you just you just make a query. Give me employee department and employee name of employee whose employee ID is 1. You get the answer. That is what is the solution. Now this is the theoretical part. Now come to implementation. How do we implement it? So this is what we have discussed now. This is what exactly is done in a merge. What we'll see, join or merge. Guys, any questions so far in the theory, in understanding at least? Then we'll see the implementation. Fine, no questions. So let's go ahead. I create two data frame. Data frame 1. Okay, great. Yeah, so I'll create two data frame. Data frame 1 and data frame 2. So let me check what we have in data frame 1 and data frame 2. What I have is I have customer ID and product. Okay, what I have in data frame 2, I have customer ID and state. Now what can be the case? I want to find a customer who is buying, like all the customers. Let's say I want to find, let's make it simple. I want to find a customer who's from Alabama state. This can be one situation. Or you want to find in from which state your customer belongs, whose customer ID is 3. This can be one situation. You can drive a number of such situation here, but the idea is you have two tables, two data frame, okay, in which you have customer ID and product. First one, second one, you have customer ID and state. Now if you want to find anything which is not, which is not there in the first table, so you have to merge it. Okay, how do we merge? So merge has very, like, lots of varieties in merge. Okay, you'll initially you'll get confused. Okay, so the best way to start is question R about merge. Okay, and see the variety. You have left merge, right merge, outer, inner, like n number of things will be there. Okay, and on what you will be joining. So that is most important. So the first example which you see here, try to understand this. Okay, this will clarify at least some percent, like 10 to 20% of your doubts here. Okay, so X is your first table, Y is your second table. By means what is your common column. Okay, what I mean by common column is the merging or the join will happen on common column. Okay, let's say here you see 1 2 3 4 5 6 in the first table, and the second table you see 2 4 6. Okay, so all the elements which is common here, 2 is there, 4 4 is also there, 6 is also there. So all the common columns will be merged. Okay, that means this particular value will come and sit here with this. There will be one more column created, state, and column with customer ID 2 will get populated here, Alabama. For 4, this value Alabama will come and sit here. Okay, then for 6, the Ohio will come and sit here. Okay, and all means true, means like join all. This is an outer join. How do we join? This makes a difference. Okay, whether it be, so the variety is, I'll just mention the variety. Okay, you have outer join. For this you need to write all is equal to true. Okay, then you have left join. Left join. So what I mean by left join, I'll just try and tell you here. Yeah, sorry, close this. What I mean by left join is whenever this comes on your way, left or right, so just keep this theory in your mind, draw a picture of it, okay, in your mind. If you are doing outer join, that means all is equal to true, means like I'm not bothered about which table is on left side, which table is on right side, no issues. But the concept of this merge is coming from SQL. Okay, and in SQL, when we write join, let's say left right, whatever it is, left join, right join, okay, outer join, whatever. So what does this left and right, what is the relative reference point? So reference point is the time we write join. So the table on the left of join, the table which is here, let's say table X, okay, is your left table. Okay, table on the right of your join is your right table. This is how I understand, and this always works for me. Okay, so this can be confusion initially, but this is how I remember. Now same thing will be applied here. Okay, now if I write, where is the code? Sorry, uh, yeah, I was writing here. Now if I write merge, okay, and I want to merge what? df1, let's write like this way, x is equal to df1, comma, tab y is equal to df2. Then you'll have to write how you have to join. All dot x is equal to true, all whatever. So I'll write first outer join. So outer join means all is equal to true. That means outer join. Forget about it. No left right. Now come to second scenario. Second scenario will be merge x is equal to df1, y is equal to df2, comma. Okay, so left join means if I'm writing join, so left side of it, whatever table is, it is left table. Okay, right side is your right table. So here all dot x is equal to true. This means your left join. As I said, this concept is coming from SQL. So I'll just tell you how in SQL we write. Okay, so the statement in SQL looks like this: select star from some table 1, left join table 2, table 2. On what I want to join? What is the common table, common column? On customer ID. Something we'll write like this. Okay. So this join, the left join. What we mean is, on the left side, the table, whatever the table we have in the left side, we want all the data from the left table. This is what I mean by left join. And which is your left table? The table which is coming before join, table 1. Okay. The moment I write right join, so what I mean is, I want all the data from the right table. Okay. Now come to R. This we'll see when we start SQL. Okay, and the basics of SQL, we'll see this. Okay, but now since we are into R, try and understand the consequences and the concepts here. Okay, so all is equal to true means I want all the data set, like from X and Y, irrespective of it matches or not. Okay, now see the result. Once you see the result, you will get to understand. See here, what I'm getting is, I'm getting which is common. As I said you, Alabama 2, 4 and 6 was common in both the table. If you remember, if you see the data set here, see the data set 2, 4 and common is common. 2, 4 and 6 is common in both the tables, df1 and df2. So we got the data, and that is what was expected. But since we used outer join, and outer join states all is equal to true, that means I want all the data set from both the table. Okay, so there will be no missing values. You'll get all the columns. See, nothing is missing. Okay, but if you specify, hello, yeah, so yeah, I'll tell you. Wait, we'll see that. So yeah, so the idea is, in all, we write, we mean like, whatever is matching, that will definitely come in, but irrespective of that, I want all the data set. So we got all the data set. Okay, now when I'm doing left join, this is your outer join. So we call this as outer join. When we want all the data set, we call this as outer join. Outer join. When you specify x dot is all dot x is equal to true, that means x is what? df1. Okay, so all the data set from df1 will be there. Okay, and the matching data from df2. Now left join. Try left join. Try and understand this. Okay, now before I run and get the output, we'll see what is the expected, what can be the expected result. This is my df1, this is my df2. So all the data set from df1 will be there, and the matching data from df2. So definitely we'll have everything from 1 to 6, right? Let me know if you don't agree with my point. Right join. So in right join, what will we have? What we'll have is same code, just all dot y is equal to true. Okay, let's run this. Let's run this. Yeah, let's run this. See here. Now the thing is, here you see all the data set from the left as well as right, because you don't have anything uncommon here. If you have anything uncommon here, okay, you will not get that. That was the point. Let's say you have 2, 4, 6 and 8, and 8 does not exist in table 1, so you will not get that. Since both have common, so you got all the data set. Come again. Why are we not writing common columns in case of auto join? Means see, in R it automatically handles. Okay, when we write SQL queries, so in that we specify what is a common column. But here we don't need to specify. We can specify, but we don't need to specify what is a common column. Okay, fine. So this is the three varieties that you need to look at. Okay, perfect. So this is the only three varieties that you need to look at. Okay, auto join left and right, and this is a query which I have sent you. Okay, and you were talking about this, right? By what is a common column? You can specify this as well, but it is not needed. It is not mandate. Okay, now start. You can run this query as well. Like just run and see it how it goes. Okay, it works the same way. Yeah. So the difference is on a right join. In a right join, what I'm specifying, all dot y is equal to 2. That means I want all the column from right table. That is df2. All the column from the all the rows from the right table. That is df2. That is it. So see here, we got the filtered data here, because since in right table we have limit only 3 columns, so we got only 3 columns. Okay, and the remaining is filtered out. So that is what happens. Okay, cross join means like it will do Cartesian product. If you are aware of Cartesian product, so if you just recall a Cartesian product from a subset theory, so it follows the same law. It will multiply each column or each row with the other table row. So that means if if you run this, okay, it gets multiplied m into n times. That was the law. So if a table 1 has m rows and a table 2 has n rows, so the resulting table here will have m into n rows. Okay, normal Cartesian product. Fine. So I guess this is done. I'll share the code with you, and probably I'll yeah, the coming back to assignments. So assignments link I'll share in the mail. Okay, so these are the assignments which I've opened here. This is in this is the two assignment which I've opened here, which I'll share with you. So it covers the basic concepts of data types. Okay, and vectors, metrics, and all that. You need to you have this all is multi MCQ. Okay, the best part is you'll have to execute the code in your R. Okay, then only you'll get the output, and I need the output. Okay, correct. So just have a look into this. You will get a metrics, few metrics, then you will get calculations. Okay, operators, the operators which we have discussed in which exist in R, and you have MCQ. Just run the code, see the output, match the answer with the assignment. Okay, and solve it. Fine. So guys, I guess that is it for today. Okay, I'll share the code in some time and recording as well. So go through it once, and probably next Saturday